cases. The first one, when the roots are different, okay, and they are real. Okay, these occur when b square minus 4ac greater than 0, and when your y will be c1 e r1x. R1 is what? Your first root, and then plus c2 e r2x, where r2 is the second root. Okay, this when you have two different real roots. Okay, we have done the example. In the second case, when you have a repeated root, where r1 equal to r2, okay, and then your y, your general solution will be in this form. Okay, c1 e to the power of rx plus c2, you multiply with x here, e to the power of rx. Okay, we multiply c2 with x, so that those two, this is y1, this is y2, they are independent. Okay, this is y1, this is y2. Okay, we multiply y2 with x so that they becomes independent. Okay, we have done few example. For the case 3, okay, when r2 and r1 and r2 are complex, okay, this occur when b square minus 4ac less than 0. Okay, so r2 will consist of the real part and the imaginary parts. Okay, so the real part is okay. So both alpha and beta are real numbers. Okay, and then the solution will be in this form. Okay, e power of alpha x. Okay, alpha is this part. Okay, plus times c1 sines beta x. Okay, beta x is what? This part, all right? And then plus c2 cos beta x. Okay, and then we also did some example to get general solutions. Okay, and then we also, okay, we can also find the particular solution. Okay, if the if the conditions are given. Okay, so the conditions similar to the first order ODE, okay, is either comes in initial or boundary. Okay, whether it's initial condition or boundary conditions, we use those conditions to find the value of the constant, so that we can obtain the general solutions. Okay, we have done this before. Example 5, we have done this. Okay, so that is how you find. Okay, you solve a homogeneous second order linear with constant coefficients. Okay. Today, okay, we will learn how to solve second order non-homogeneous equations. Okay, non-homogeneous equations. Okay, recall that non-homogeneous second order equation, if we have this form. Okay, this is non-homogeneous for n order. Okay, linear differential equations. And when n equal to 2, and also when gx is not equal to 0, okay, when gx equal to 0, we have homogeneous case. When gx not equal to 0, okay, we have non-homogeneous. When n equal to 2, we have second order. So we can reduce this equation number 1 into equation number 2. So we have a2x, okay, y double prime plus a1x y primes plus a non xy equal to gx. Okay, the highest order is 2. Okay, and then the coefficient of y double primes is in terms of x and constant, free from y. The same goes for coefficient of y primes. Okay, is also in terms of x and constant. Okay, there is no y involved. And then the same goes for the coefficient of y, which is a non x. Okay, it only consists of x and constant. Okay, so now we want to make it simpler. Now we assume that a non x, a1x, and a2x a1x and a0x, we assume they are all constant. Okay, so the equation number 2 can be written as this, as equation number 3. Okay, where a to x equal to a1x equal to b, okay, a0 x equal to c. So we have now non-homogeneous second order linear equation, okay, with constant coefficients, right? So to solve this, okay, today we will learn two techniques to solve this, right? The first technique is called methods of undetermined coefficients. The second one is called method of variation of parameters. Okay, there are actually there is more than this. Okay, but this is the well-known one. Okay, method of undetermined coefficients and method of variation of parameters. Later on, I think next week probably you can find we will find this solution by using reduction method. Okay, but today two methods. Okay, method of undetermined coefficients and also variation of parameters. Okay, it's very crucial. Okay, uh, um, to to know which method to use. Okay, when to use undetermined coefficient, okay, when to use variation of parameters, when to use reduction methods. Okay, because each method again have different procedure to solve. Okay, to solve. All right. To solve non-homogeneous, to solve these equations, non-homogeneous second order linear with constant coefficients. The solution consists of two parts. Okay, one is the corresponding to homogeneous, okay, and YP, okay, corresponding to, we call it the particular, can be obtained from particular integrations. Okay, you obtain from this table. Okay, for previously in homogeneous, we only have y equal to yh. Okay, y equal to yh. That's for homogeneous. But since we are dealing with non-homogeneous, okay, first you need to find the general solution for homogeneous, and then plus we need to add this solution with ypx. So ypx is, we call it particular solutions, but it's not the same as the particular solution that, in the sense that we need to find C. No, this yp correspond to the table of non-homogeneous equations. We refer to this table. Okay. So this consists of two solutions, YH and YP. YH you have learned to find YH before. Okay, so now we need to find YP from this table. Okay, what is YP? Okay, suppose, YP is a particular integration of y double prime plus by prime plus c equal to x. So this is second order linear with constant coefficients. Okay, and we know that gx is not equal to 0 because this is non-homogeneous. Okay, now we focus on gx. Okay, if gx is in this form, which is polynomial of order n, okay, an x power of n, okay, plus an minus 1 times a to the power of n minus 1 up till a naught, up to the constant. So this is polynomial of order n. Okay, if gx is in this form, and then the trial solutions for yp. Okay, yp may be in this form. We are not guaranteed yet. May be in this form. For a start, we put yp as this. All right. Okay, later on, I will explain why sometimes it's not necessarily in this form. All right. And then if gx in the exponential form, so is in a to the power of alpha x in this form, and then your trial solutions for yp is in this form. Okay, k, sum is constant, times e power of alpha x. Okay, and if gx in cos beta x in this form, and then your yp, you should consider yp as a naught is constant, sines beta x plus a1 cos beta x. Okay. Also, if gx is in this form, sines beta x, yp is the same. Okay. Yp you should consider a naught sines beta x plus a1 cos beta x. So when you have cos or sines, yp is the same. Okay. We cannot separate cos and sines. Why? Because if we differentiate cos, okay, we get minus sine. If we differentiate sine, we have minus cos, and that's why we cannot. They comes together. Okay, sines and cos come together. Okay, the fifth type. Okay, when we have polynomial, which is equation 1, multiply with equation number 2. So it's a combination of exponent and also polynomial. Okay, so in this case, okay, yp is in this form, the polynomial, okay, times with the polynomial times with the exponent. Okay. Okay, similarly, when you have equation 1 and equation 3, is a multiplication of equation 1 method 3, or equation 1 times equation 4. Okay, your yp will be in this form. Okay, polynomial times sines beta x, okay, plus another polynomial. Okay, this one is different from this, huh? Okay, times cosine x. All right, times cosine x. Okay, so you can always refer to this table, okay, to find yp, the trial solutions. It's not confirmed yet. For the first time, okay, you try this first. Okay. All right. Okay, how to solve a second order linear with constant non-homogeneous linear second order with constant coefficients? Okay, there are several steps. Okay, the first step, you know that to find the solution y is a combination of yh and yp. Okay, so where yh is the solution corresponding to homogeneous equation, and yp you can get it from the particular integration from table 1. Okay, shown just now. All right, and then you need to find yh. Okay, you reduce this. Okay, now gx becomes 0 because you want to solve for homogeneous. Then from here you can get yh. Okay, to find yp, okay, you choose the appropriate, okay, the appropriate trial solutions. Okay, here, okay, so you refer to gx, and then you choose the appropriate trial solutions to find yp. But now, okay, if any terms in trial yp appear in yh, meaning that you need to compare, okay, your trial solution of yp with yh from here. You need to compare each terms, okay, each term of yp and yh. If the terms is the same, then you need to multiply yp with x. Okay, and you check again. If they are the same, you multiply with x squared. You have the same, then you multiply with x cubed and so on. Okay, or in other words, you multiply yp with x power of k, where k is the smallest integer. such that no terms in yp it is the same as yh. Okay, later on you will understand it. You will understand it better later on. Okay, and then in the fifth step, okay, so if there is no terms in trial yp appear in yh, then that will be our yp. Okay, that will be our yp. Okay, and then so now we need to find the first derivative of yp, plug into here, okay, and the second derivative plug to here, and then you will find after that you need to find the unknown coefficients. Okay, in order to understand this step, let's see example 8. Okay, let's example 8. Okay, determine a suitable trial solutions for undetermined coefficients in each case. Okay, for A, y double primes minus 4y primes plus 4y equal to 3x squared plus 4e to the power of minus 2x. So when you refer to gx, is a combination of polynomial and also exponent. Okay, it's a combination of polynomial and also exponent. Okay, first we need to find the solutions to the homogeneous, right? So y double primes minus 4y prime plus 4 equal to 0. Okay, we make the right hand side become 0. So you need to find yh. Okay, so you have learned before how to find the solutions to these homogeneous equations. Okay, you transform the given equation into characteristic equations, which is what? Y double prime, you have r squared minus 4y primes, replace y prime with r, and then plus 4y, replace y with r power of 0, but y power of 0 is equal to 1, 1 times y equal to 4. So when you convert this into characteristic equations, which is r squared minus 4r plus 0. Okay, so to find r, okay, we can use either what? We can use either quadratic formula or also factoring. Okay, in this case, we use factoring. So we have r minus 2 times r minus 2, because r squared minus 4r plus 4 can be written as r minus 2 times r minus 2. Okay, meaning that we have repeated roots. Okay, because b squared, b equal to minus 4. Okay, b squared, which is 16, minus 4 times a, 4 times 1 is 4. Okay, times 4, 16. So 16 minus 16 equal to 0. And that's why we have repeated root here. Okay, which is 2. Okay, so when we have repeated roots, okay, yh will be what? C1 e, okay, e rx, so e2x plus c2x. So repeated root, we multiply c2 with x, e rx, so e2x. Okay, so we have found yh. Okay, let's try solutions. We have 3x squared, which is polynomial of order 2, right? Of second order. So now we have, okay, we have here, right? This polynomial where n is equal to 2. Okay, and your star solution will be a polynomial of order 2 as well. Okay, and that's why now yp corresponding to 3x squared, okay, will be this. Okay, b0 plus b1x plus b2x squared, or you can reverse, okay, reverse the order. You can write b squared, b2x squared plus b1x plus b0. They are the same. Okay, You can either write B0 plus B1x plus B2x squared, or you can write as B2x squared plus B1x plus B0, right? So this corresponding to 3x squared. Okay, this is polynomial of order 2, okay? And your trial solution will be polynomial order 2. You will, okay, we will stop till we get to the constant terms. Okay, we cannot simply put like this. Okay, that one cannot. Okay, we got to go on until we have the constant. Okay, all right. Okay, this corresponding to 3x squared. And the second term is 4e power of minus 2x. So this is exponent. So you refer to this table. Okay, this one. So YG in this form. Okay, and then your trial solution will be in this form. Okay, constant times this exponent, right? And that's why your YP corresponding to 4e minus 2x is k, e power of minus 2x. Okay, so this is the most crucial part, okay, to solve non-homogeneous second order with constant coefficients. Okay, to determine what is YP. Okay, if you get the wrong YP, the answer will be wrong. Okay, the answer will be wrong. So YP now, okay, YP now equal to, okay, this B0 B1x plus B2x squared, and then plus this, okay, plus k e power of minus 2x. So this is your YP, right? Next step, you need to compare. Okay, you need to compare each term in YP, okay, with each term in YH. Okay, so I bring this here so that it's easier for us to compare. Okay, compare YH and YP. Okay, so B0, okay, compare with this. They are not in the same term, in the same form. Okay, and then B1x, compare with this and this, not in the same form. But this one have exponent, this one not. Okay, and then B2x squared, okay, not in the same term because this one have what? Exponent, this one not. And when you compare this, okay, okay, and then you also compare this, okay, compare this with this. It's not in the same form because this one is e power of 2x, while this one is minus 2x. So they are not in the same form. Okay, so now YP is this. Your final YP will be this. Okay, so after comparing all the terms, so they are, and then each term in YP is not the same as each term in YH, and your YP is this. This is your final YP. Okay, this is the most, again, the most crucial step. Okay, is any questions? Any questions? Siapa yang tak clear? Siapa yang tak clear this step to determine YP? Azlin, Nur Azlin, is it okay? Nur Azlin, are you there? Nur Azlin, are you there? Okay, how about Yamini? Are you okay, Yamini?
Yes, sir, I understand.
Clear?
Yeah.
Clear?
Yes.
All right. So I will proceed. Okay. So for case B, okay, for case B, it's very clear that, okay, it has the same as YH as compared to what? As in A, because both have the same, okay, this is what? This is the same second order linear Wisconsin coefficients. When this becomes 0, when the right hand side becomes 0, they are the same. I mean, homogeneous are the same, right? So we will have the same YH. So when we change on the right hand side, we turn into 0, they are equivalent. So we will get the same YH. The YH remain the same, which is C1 e to x plus C2 x x e to x. Okay, and when your YP now, YP is different. Okay, YP is what? 5x, okay, times e power of 2x. Okay, 5x times e power of 2x. Okay, 5x is what? Polynomial of order 1. Okay, 5x is a polynomial of order 1. You multiply with exponent. Okay, so it's a combination of exponent and also polynomial. Okay, when you refer to this table, okay, so you multiply the polynomial and also exponent. So you have this. Okay, you have this form. Okay, polynomial times exponent, and that's why your trial solution will be in this form, right? Because these correspond to 5x, which is polynomial of order 1, which is b0 plus b1x, okay, polynomial of order 1, and then times this exponent, which is e to x. Okay, if you expand this, you will get b0 e power of 2x, okay, plus b1x e to x. To expand this. Okay, the next step, you need to compare this term in YP with YH. Okay, you compare b0 e to x with this. Okay, b0 is a constant, c1 is a constant. Okay, this is polynomial of 2x. Sorry, this is exponent of 2x. Exponent of 2x. So they have the same form. Okay, b0 e to x, okay, and c1 e to x, they have the same form. And then that's why we need to multiply yp with x. Okay, so we multiply yp with x. Okay, here they multiply with x. Okay, and then we expand. Okay, and that's why we have b0 e to x plus b1, because x times x is x squared, so b1 x squared e to x, right? And we have to compare again. Okay, b0 x to x, compare with, now they are different. Compare b0 x, okay, e to x with c2x e to x. Okay, b0, c2, constant, x and x, same variable, then e to x, same variable. So b0 x e to x has the same form as c2x e to x. And that's why we need to multiply yp again with x. Okay, so we multiply with now x squared. This one multiply with x, and then this one another x, so we multiply with x squared. So that's why we have here x squared, and then we expand this, so we have b0 x squared e to x plus b1 x cubed e to x. You compare again each term, b0 x squared e to x with this, not the same. Not the same, because now we have x squared, but here there is no x squared. And then we stop. Okay, so this will be our YP. you have to compare B1x cubed with E2x also, okay? But they are not the same. They are not the same. So we stop here. So this will be our YP, which is B0 x squared E2x plus B1 x cubed E2x. Okay. Any question before I proceed? Zaharuddin, are you there, Zaharuddin?
Yes, sir.
Faham tak, Zaharuddin?
Setakat ni boleh lah.
I tak mau boleh-boleh lah, Zaharuddin. Tak
Setakat ni
clear
faham.
kan? Faham clear, 100% faham. Kenapa tak convincing, Zaharuddin? Tak. Okey ni. Truly, you faham betul-betul?
Kena buat latihan sikit saya rasa.
Okey. Tak apa. How about the rest? Siapa yang tak faham?
Saya tak
Let
faham,
us
sir.
read. Rahman kan ni?
Saya.
Okay, Rahman. Tak faham,
Yang
Rahman.
yang kedua yang nombor 2 ni.
Okay, this one okay kan, Rahman kan? But
Okey,
this
okey.
is
Yang bawah tu.
problem. Bawah ni kan?
This one. Ramai dapat yang ni B note tambah B1X ni.
Okay, sini Rahman. Okay, because kat sini ni your gx in this form, right? So
Okay.
in B, gx will be 5x times e power of 2x. So your gx is in this form. Okay. So now, so 5x, Rahman, is what? Is a polynomial, right? 5x, polynomial of order 1. Okay.
Okay.
And then multiply with exponent e2x. Okay, and then Rahman, you go to the table, to this table, tengok kat sini. So dia ni polinomial, dia darab dengan exponent. So you multiply 1 with 2, right? Equation 1, polinomial, darab dengan equation 2, alright? And dia punya, your trial solution will be what? Again, polynomial, okay, and also exponent. Ini.
Yang tu tak pasal.
Refer to this table. Okay. Kalau dia punya exponent dia macam ni, exactly the same. Exactly the same. Kalau polynomial order n, ini pun order n juga. Tetapi dia punya coefficient berlainan. Di sini an, di sini bn. Berlainan. Tapi order sama. Okay. So you refer to this, Rahman. Refer to this. Okay. Yang ini 5x, polynomial of order 1. Okay. And then darab dengan exponent e2x. So that's why kita darab exponent dengan polynomial of order 1. Okay. But trial tu dia kena sampai habis, sampai constant. Kita tak boleh buat macam tu saja, tak boleh buat macam ni saja, tak boleh buat macam tak boleh. Okay. Sebab trial tu sampai habis, sampai constant, kita stop. Kita tengok sini, kita stop sampai dia jadi constant. Kena pergi habis. Okay. Kalau kita ada x square, kena bn x square plus bn ni sampai b0. Clear tak, Rahman?
Okay.
Okay. Okay. So siapa lagi yang tak faham? Okay, Rahman. And then lepas ni, okay. So this will be our initial trial solution, Rahman. So kenapa I expand? Sebab senang nak tengok terms. Okay. So I expand this. We will get b0 e to x plus b1x e to x. Are you with me, Rahman?
Okay, sir.
Okay,
Yes.
and then Rahman, you need to compare b0 e to x dengan terms, dengan each term, setiap terms dalam YH. Okay, in fact you have to compare b0 this dengan C1 dan dengan yang tu. Compare. Okay. Kalau sama sekalipun, you kena darab YP with X. Okay, so I check yang ni dulu. This one, darab ni, check yang ni, sama. Okay, because this one constant, C1 constant, B0 constant, and then exponent pun sama. Asalkan sama saja, I multiply YP with X. That's why I multiply yang ini dengan X. Boleh?
Okay, boleh.
Okay, and then you kembangkan. Kenapa kembangkan? Because senang nak tengok, nak compare. And then now we have B0 X e to X, B1 X square e to X. Ramai you once dia sama, yang ni tak perlu compare lah. Tak kisah.
Kalau tak sama?
Tak payah, asalkan sekali tak sama, cukup.
Oh.
Tak, kalau you buat jangan buang masa. Asalkan sekali tak sama, tak kisah you compare this, tak kisah. Asalkan sekali tak sama, you darab dengan X. Okay.
Oh,
Now
okay.
you multiply this with okay, you get this. Now you compare this with this. Tak sama. Tidak ada X kat situ. Compare this with this. Okay. Sama lagi. Okay. So you boleh compare kat this and this. Tapi buang masa. Okay. Asalkan sama, multiply with X lagi sekali. Okay. Now you multiply with X square. Okay. So you expand, you have B0 X square e to X plus B1 X cube e to X. Tengok sini, compare lagi. Okay. Tak sama. Tak sama. And then you kena, yang ni bila dua-dua tak sama, compare ni pula. You compare this pula. Okay. You tak boleh stop, compare this pula. Compare, tak sama juga. Okay, compare this and this, tak sama. Semua tak sama. And then this is your YP.
Oh.
Okay. Okay, this is your YP. Right. Yang the rest faham ke? Yang the rest? Because this is the most crucial part. Silap YP, the rest akan silap. Okay. In example C, y double prime plus 2y prime plus y equal to 3e power of x cos 2x. Okay. So here gx is a combination of exponent and trigo. Okay, exponent and trigo. Okay, first we need to find yh. Okay, to find yh, we let gx equal to 0. So now we have y double prime plus 2y prime plus 5y equal to 0. So we have homogeneous. Okay. So now for C, so we have y double prime plus 2y primes, okay, plus 5y equal to 0. Okay. And then we transform this equation into characteristic equations. So this one will become y double prime become r square plus 2y prime times plus 2r plus 4y, 5y, 5 r power of 0 is equal to 1, so plus 5 equal to 0. We know that b equal to 2, okay, b square, that means 2 square equal to 4, minus 4 times a is equal to 1, 4 times 1, we have 4, times 5, 20. So we have what? We have 2 minus 20. Okay, so 4 minus 20, which is minus 16. So now we have complex root. Okay, when you solve this using quadratic formula, so we have r equal to minus 1, okay, plus minus 2i. You will get this. Okay, so r equal to minus 1 plus minus 2i. So alpha is equal to minus 1, beta is equal to 2. Okay, so your YH will be e to the power of alpha x. So alpha is equal to minus 1. So that's why e minus x times a naught sines beta x. Okay, sines beta x plus beta x is equal to 2 sines to x plus a1, okay, cos beta x. Beta x is equal to 2 as well. So this is going to be your YH. Okay. So for YP, For YP, we refer to this. Okay, we refer to this. YP is a combinations of exponent and cos. Go to the table. So you have a combination of exponent, okay, which is number 2, and then times 3 go is 3. Okay, a combination of, so equation 1 times equation 3. Okay, what is the trial solution? Okay, sorry, 3, 2, and 3. So here, okay, 2 and 3. So it's a what? It's a combination of exponent and also 3 go. Okay, A naught sines beta x plus A1 cos beta x. So we go back here. So your YP should be in this form. Okay, a combinations, okay, a combinations, okay, of this, okay, and then this, right? But they are the same, and that's why you need to multiply YP with X to make the difference. Because before this is in this form, okay, it's a combination of exponent and also three go, but they have different coefficients, okay, but they represent constant A naught, B naught, A1, B1, okay, but these terms they are the same, so you multiply this with X, okay, YP, and now they are not, each term are different, okay, this is your final YP. Okay, any questions? Okay, so let's see example, let's solve example 9. Okay, y double primes plus y primes equal to minus 3x squared plus 7. Okay, first you need to check, is it second order linear with constant coefficients? Yes. Okay, here. Okay, all right. And then now your gx equal to 3x squared plus 7. So you have non-homogeneous second order linear with constant coefficients. Okay, the first step, you need to find YH. Okay, you make gx equal to 0. That's why we have y double prime plus y prime equal to 0. You transform this into characteristic equations. So you have r squared plus r equal to 0. You take r out, so r times r plus 1 equal to 0. That means r equal to 0, r equal to minus 1. So we have what? We have two distinct real roots, okay, where r1 equal to 0, r2 equal to minus 1. Okay, so YH will be C1 e power of R1x plus C2 e power of R2x. Okay, R2, R1 is equal to 0. So 0 times x give you what? 0. E power of 0 equal to 1. 1 times C1 give you C1. Okay, and then C2, R2 will be minus 1. So C2 e power of R2 minus 1 times x. Minus 1 times x give you minus x. So your YH will be C plus C1 plus C2 times e power of minus x. Okay. Second step, okay, solve solutions. Okay, you refer to the GX. Okay, GX is in the form of polynomial of order 2. Okay, polynomial of order 2. And that's why your initial trial solution is in this form. Okay, b2x squared plus b1x plus b naught. Okay, you can reverse the order or you can write like this. Okay, so b naught, b2x squared plus b1x plus b naught. This is what? This is your YP initials. Okay, so you compare this. Okay, you compare this with, okay, with YH. Okay, you compare b2x squared with c1, they are not the same. b1x with c1 are not the same. b naught with c1, they have the same form. Okay, this one constant, this one constant. Okay, so that's why we have to multiply yp with h. Okay, so now so yp now we multiply by with x. Okay, now we have b2x cubed plus b1x squared plus b1x. Okay, we have this, right? And then we need to compare this with h. Okay, compare each term. So I bring yh here, so easier for us to compare. Okay, this is your yh. So compare this with this, everything now, they are not the same. So each term is not the same. So that is our final yp. Okay, you stop me anytime if you don't understand. Okay, stop me anytime. Okay, so this is will be our yp. Okay, so now the next step, okay, since we are dealing with second order ODE, we need to differentiate once and twice. We differentiate yp. Okay, differentiate yp once, you have what? Differentiate b2x cubed, we have 3b2x squared. You differentiate b1x squared, you have 2b1x. You differentiate b1x, you get b naught. Sorry, b naught x, you have b naught. Okay, to get second derivative, okay, you differentiate y primes with respect to x one more times. So now you differentiate 3b2x squared, we have 6b2x. You differentiate 2b1x, you will get 2b1. You differentiate b naught, which is constant, you will get 0. Okay, you will get 0 here, 0, right? So you go back to the equations. Okay, you replace y double prime with yp double primes. You replace y prime with yp primes. Okay, so now it becomes, okay, so you replace. Okay, I think I should bring this down. Bring this down so that you can, it's easier for you to see. Okay, so you replace y double prime with yp double primes. But yp double prime is equal to 6b2x plus 2b1 from here. Okay, and then plus you replace y prime with yp prime. So yp prime is equal to 3b2x squared plus 2b1x plus b naught. Okay, so this equal to minus 3x squared plus 7. Okay, and now we have to compare the coefficients, right? The highest, the terms, the highest degree of the highest power of x now is x squared. So x squared. Okay, and then we compare the coefficient of the right hand side and the left hand side. For x squared, we have the coefficient 3b2. Okay, only 3b2. So 3b2 on your left, okay, your left coefficient must equal to the coefficient of your left or your right. Your right will be what? Minus 3. Coefficient of x squared is equal to minus 3. Okay, meaning that 3b2 must equal to minus 3. Okay, compare the coefficient of left and right. Okay, that means this implies that b2 equal to minus 1. Okay, b2 equal to minus 3 divided by 3 equal to minus 1. How about coefficient for x? Okay, for x we have b6b2 and then plus 2b1. Okay, 6b2 plus 2b1. Okay, but on your right, there is no coefficient for x. Okay, there is no coefficient for x, and that's why we have 0. Okay, so now we have 6b2 plus 2b1 equal to 0, but b2 equal to minus 1. That means 6b2 becomes 6 times minus 1 is minus 6. So minus 6 plus 2b1 equal to 0. Okay, that means you bring 6 minus 6 to the right hand side. That means 2b1 equal to 6. So b1 equal to 3. Okay, so b1 equal to 3. And now you compare the coefficient of constant. Constant means x power of 0. So you have 2b1 okay, plus b0. Okay, I mean 2b1 plus b0 equal to 7. Okay, so we know that b1 equal to 3. 2b1 equal to what? 2 times 3 equal to 6. So 6 plus b0 equal to 7. That means b0 equal to 7 minus 6 equal to 1. Right? So we have found b0, b1, b2. We go up there. We replace b0, b2, b2 with minus 1. Okay, b1 with 3. And then b0 with 1. So we have this. Okay, so now we have b2, okay, and then b1, and then b0. So yp is in this form. Are you guys okay now? Okay, yp equal to this. Any questions? Kenapa hari ni kelas tak semangat ni? Semua
Sir,
puasa
can
ke?
you- Sir, can you explain again for the step 2?
This one, yes? Step 2.
Yeah.
Okay.
Like
alright.
compare the YPX and
Okay.
YHX.
Okay. May I know your name, please? I cannot see your name here. May I know your name?
My name is Yip.
Yip. Okay, Yip.
Yeah.
This step you faham, Yip? YP in this step you faham?
Yeah,
You
this one I
go to-
understand.
You understand. You refer to the table, right? Polynomial of order 2. Okay, now Yip, you compare this. Okay, you compare this. Okay, B0, YP, right? B0 is a constant, right? Yip.
Yeah.
Okay, and then okay, now okay, we compare with YH. So what is our YH? This is our YH. I think I put here, copy here. I copy, put side by side. Okay. Okay, Yip, you compare Yip. Okay, B not x square with this. Not the same, right? Yip.
Yeah.
Okay, compare B2x square with not the same form. Okay, you compare B1x with this, not the same form. There is no x there. You compare B1x with C2EX, not the same form because this one has exponent. But you compare B0 with C1. This is constant, B0 constant. They have the same form. Is it not? It.
Sorry?
C1, C1 in YH has the same form as B0 in YP. Okay, because they are both constant. Constant.
Yeah.
Are you okay?
Yes.
Are you okay
I'm
now,
clear.
Yip?
Yes.
Okay.
Yes.
So now, okay, that's why we need to multiply YP as long as there is one of the terms are the same, is the same, then you need to multiply the whole YP with X, the whole with X. And that's why we have this Yip. So YP now, you multiply y, okay, yp with x, now you have b2x cubed plus b1x squared plus b0 x. That's why we have this term. Are
Okay.
you with me yet?
Yes, yes,
Okay,
understand
now,
already.
okay, okay, I will make sure that you understand completely. Okay,
Okay.
compare again. Compare, not the same, not the same. Compare is not the same. Now they are not. None of the terms are is the same. Yeah. Then we stop. Okay, then we stop. Okay, and then you take the first derivative, second derivative, you plug into the given equation here. Okay, and that's why we have this. And then to find, so our task now to find B0, to find B1, to find B2. And that's why we call this method as undetermined coefficients, because we need to determine the coefficient of B0, B1, and B2. In order to determine B0, B1, B2, we need to compare the coefficient of the right and also on the right, on the left. Okay, so now x squared, so we need to compare the coefficient of x squared, the coefficient of x, and also constant. X0 is a constant. Okay, you compare, and this is our yp. Okay, and then yp is equal to minus x cubed plus 3x squared plus x. So y will be, now x will be what? Yh plus yp. So yh is equal to c1 plus c2 e power of minus x, and then is equal to minus x cubed plus 3x squared plus x. So this is your general solutions, okay, for, okay, to the given second order linear with constant coefficients. Okay, this is general, because to find C1 and C2, okay, we need to have initial conditions. Okay, we need to have initial conditions. So any questions? Any question now? All right. Example 10. Example 10. Okay. Y double prime minus y primes equal to x ex, okay, is second order linear constant coefficients, okay, and then you are given initial conditions when x equal to 0, y equal to 2, okay, when x equal to 0, y prime is equal to 1. Okay, the first step, okay, we want to find yh. You make gx equal to 0, so you have y double prime minus y prime equal to 0. Okay, so that means we have r squared minus r. You transform this into characteristic equations. So r squared minus r equal to 0. That means r times r plus minus 1 equal to 0. So r1 equal to 0, r2 equal to 1. So your yh will be c1 er1x plus c2 er2x. Okay, because r1 is equal to 0, we have e power of 0 equal to 1. So we have c1 plus c2 r2 equal to 1 times x, so you have ex. So this is your yh. Okay, your trial solutions, you need to refer to gx here. So gx here is a combination of polynomial times exponent. The polynomial of order 1 times exponent e power of x. So that's why your yp will be what? B0 plus b1x ex. Okay, sampai constant, right? Order 1 ex. So you expand this as before. Okay, you compare each term in yp with each term in yh. Okay, you compare this again. This, okay, this is as the same form as C2ex. Okay, B naught is constant, C2 is constant, and then the same exponent, they have the same form. That's why you need to multiply YP with X. Okay, now you have B naught X EX, okay, plus B1 X square EX. Then you need to compare again. Okay, compare again B naught X EX with this. They are not the same. C1 is not the same. B1 X square EX compare with C1, compare with C2 EX, they are not the same. Then we stop. Okay, we stop. Next, we need to find the first derivative of YP. Okay, to differentiate B naught X EX, we need to use product rule. Okay, because X appear here and also there. Okay, so the derivative of B naught EX will be B naught EX. Okay, B naught X. You differentiate EX, you have EX, and then you maintain B naught EX. You differentiate X, you get 1. Okay, so this is the result of this. Okay, to differentiate B1 X square EX, this is U, this is V. Maintain U with B1 X square. Differentiate EX, we have EX. Okay, you maintain EX. You differentiate B1 X square, you have 2B1X. So you have 2B1X. Okay, this, right? So this is your YP prime. Okay, to find YP double prime, you differentiate each of these terms. You differentiate this, we get the first two terms. Okay. Then you differentiate B naught EX, you have B naught EX. You differentiate B1 X square EX, you have 2B1 X square EX plus 2B1 X EX. Okay. You differentiate 2B1 X EX, you have 2B1 X EX plus 2B1 EX. Then you simplify this, you will get B naught X EX plus 2B naught EX plus B1 X square EX plus 4B1 X EX plus 2B1 X. Okay, and when you plug into here, you replace X Y prime with YP primes. You replace Y prime with YP prime. You replace Y with YP. Okay, and that's why you have here. Okay, here is Y prime, Y double prime. So you replace with YP double primes. Okay, this one is Y double primes. You replace with YP double prime. You replace with this, the whole thing. Okay, minus Y primes. Okay, minus Y primes. Okay, minus Y primes. Replace Y prime is YP primes. Okay, YP primes. So this is YP primes equal to X EX. Okay, and then you reduce and then you simplify all these terms. So you have what? B naught EX, because B naught X and X, B naught X cancel. And then we have B naught EX minus B naught EX, you have B naught EX, okay, plus 2B1 X EX plus 2B1 EX. Okay, you simplify this, you will get that. Okay, and this one equal to, this expression is equal to X EX. Now you need to compare the coefficients. So the coefficient now, here we have X EX, right? And the coefficient is what? The coefficient is 2B1. Okay, 2B1. Here we have 1. The coefficient of X is equal to 1. That means 2B1 equal to 1. This implies that B1 equal to 1/2. Okay, now for the coefficient of EX, okay, EX, for EX we have B naught, okay, plus 2B1. Okay, so B naught plus 2B1 equal to, there is on your right, so must equal to 0. So we replace B1 with half there. So we have B naught plus 2 times 1/2 equal to 0. 2 times 1/2 is equal to 1. So B naught plus 1 equal to 0. This implies that B naught is equal to minus 1. Okay, we go up there. We replace B naught with minus 1, B1 with half here. Okay, So we will get this. Okay, so minus, okay, minus x ex. Okay, this one is b naught. Okay, and then a plus, okay, plus 1/2. Okay, 1/2 x squared, and then the general solution will be this. Okay, yh plus yp. So this is yh, this is your yp. Okay, and then to find C1, C2, say you use the initial conditions, which is when x equal to 0, y equal to 2. To replace here, you replace y here with 2. Okay, 2 equal to C1 plus C2e, you replace x with 0. Okay, 0, 0, and then plus 1/2, 0 squared, plus e power of 0. Okay, now C1 here plus C2 times 1. So C1 plus C2, here we get 0. Here we get 0. So we have 2 equal to C1 plus C2. Okay, use another initial conditions. When x equal to 0, y prime is equal to 1. You go to y prime, you go to y prime, you replace, okay, you replace this. Okay, your y primes, okay, your y primes will be, you refer to y prime will be what? 0, okay, plus C2ex. This one you got to use product rule. Okay, plus you use product rule. So your y prime equal to this, right? C2ex minus x ex plus ex plus 1/2 x squared ex plus 2x ex. You have to take the first derivative of this, right? I upload the note. You can refer to the note here. So see y prime equal to this expression. So replace y prime this one. Okay, x with 0 here. So you will get 1 equal to C2 minus 1. Okay, all this one is 0, 1, 0, 0. Then you have C2 times 1, C2 minus 1. So 1 equal to C2 minus 1, C2 will be equal to 2. So you go up there, replace C1. Okay, you replace C1. Okay, you have C2 equal to 2. So you can get C1. So 2, you go to these equations. 2 equal to C1 plus C2. C2 equal to 2. So C1 will be 0. Okay. So you replace C1 with 0, C2 with 2. So you will get, okay, so your YH now become, your YH now become, where is your YH? Become now, okay, become, Z1 is 0, right? So become 2EX. Your YH now becomes 0 plus 2EX. So that means 2EX. So you replace, so Y equal to YH, YH equal to 2EX. YP, you have obtained YP before, is YP, and that is your specific solutions. Okay, so that is your specific solutions. So Y equal to 2EX, you got from YH, okay, minus x EX plus 1/2 x squared times EX, you got from YP. Okay, Y equal to YH plus YP equal to 2EX minus x EX plus 1/2 x squared EX. Okay, so that's how you find second order linear with constant coefficients, non-homogeneous. Okay, using undetermined coefficient. Why called undetermined? Because we need to find the determinant. The constant, the coefficients. So undetermined coefficients. Okay, I think that's all for today. Okay, until we meet again next week. Okay, next week.